Hi everyone. So let's take a look at some systems of inequalities where we have to shade, but word problem versions of them. You also can see that I kind of have a first quadrant graph set up for us. The reason we're only going to do the first quadrant is because a lot of these real world examples aren't going to have to dive into the negatives, which is nice, so we can kind of limit our structure to only one quadrant. But they're also going to act as sketches for us. So I do have a calculator ready to show you some of the windows that I use for the sketches. But remember, they're not graphs, they're just sketches, so they're just to give us an idea of something that can go ahead and just kind of give us an indication of what a sample answer might be. So for this first problem, you can work at most 20 hours next week. You need to earn at least $92 to cover your weekly expenses. Your dog walking job pays $7.50 an hour, and your job as a car wash attendant pays $6 per hour. Okay, so what we're going to do is have to set up a let statement where we define x and y as our two unknowns. Let x equal one of our unknowns, which is the number of hours that we end up working one of our jobs. Let's do dog walking for x. And then we'll go ahead and we'll take y, and we'll let that be the number of hours car washing. So those are just the number of hours. If we just look at them by themselves, we can total them to figure out what might impact the at most 20 hours next week part. So if we just do x plus y and compare that to the number 20, if we can work at most 20 hours, that means we can work 20 hours or under that, because we're not allowed to go over. It is the most when it's 20. So that would be less than or equal to. We also have some other expenses, money paired with the number of hours we could work. So maybe we're going and doing $7.50 an hour for the dog walking. That would be 7.5 times x. And $6 for the car wash. So that would be only plus 6y. And that's now going to be money amount earned. And we need to earn at least $92. So when we compare this to the value 92, 92 is the minimum. So greater than or equal to 92 is what we would need. Now for our sketch to try to get a sample answer, what we need to do is get these into slope-intercept style form. So for the one on the left, I'm going to subtract x from both sides, and that will give me y is less than or equal to negative x plus 20. Okay, and you can see here that means our y-intercept for this sketch is going to have to be 20, kind of giving me an indication of what I might need to go up to on my graph here. If I try to rearrange the other one, it's a little bit more difficult. One more step. I'm going to have to subtract the x to the other side, just like we did on the last problem. So that 6y ends up being greater than or equal to negative 7.5x plus 92. But now we will need to divide everything by 6. So I'll go ahead and I'll do negative 7.5 divided by 6. And that's going to be negative 1.25x. And 92 divided by 6, okay, unfortunately, and it's just going to be a sketch, so it's not a big deal, ends up being a repeating decimal. So it's 15 1/3, but you probably know by now that I prefer improper fractions instead of mixed numbers. So I'm going to write that as 46/3, which is approximately 15.3. So 20 was our higher y-intercept. The reason I'm focusing on that with you is when I move to the calculator, let me find a spot with not really any glare. There we go. I'm going to have to go up here. We can go ahead and now go to our y equals menu, type in our two inequalities, but also know basically what our window could be for the y values at least. So one of ours was negative x plus 20. That'll go in the first option. And then y2 ends up being that last value that we just got, negative 1.25x plus 46/3, or 15.3 repeating. If I go to my window, I know I'm only in the first quadrant, so the minimums can both be 0. I don't know what my x max is going to be, so we can make a guess with that. Okay, so Since it seems like 20 is going to be our y-intercept, I'll go ahead and I'll make that 20 as well, especially because the graphing space I gave you ends up kind of being square-like. So I'll try putting 20 for both, and I'll see what I get on my graph. That one looks pretty good, and that one doesn't look that bad either. So there we go. We have our sketches that we can go ahead and do. All right, so what I'm going to do is over here on our graphing space, I'm going to try to mimic the way the first one looked, which just is connecting the two corners of the graph. That's both 20, because it had a slope of -1. So we know it's going down 1 and over 1, so it's going to hit 20 over here as well. Now this spot here, we know that this y-intercept was 46/3. And when I graph it, it seems to be getting a little farther apart as I graph. So I'm going to try to kind of mimic that here as well. If you need to know what this point is, we have a tool for that. We can go to Second, Calc, and figure out the 0. So what you have to do is you have to get to the correct line, which I have to hit down to get to this line. Left bound, so I'm a little bit to the left side of where it seems to hit 0. Then I'm going to scroll over until it's off the screen, because then I'm on the right side of it. And you can see these arrows appeared up here. I think on the new calculators, even vertical lines might appear. And then I'm going to hit left again until I see the cursor flashing a little bit on the screen right there. And I make my guess. And that's about 12.26 repeating. Okay. So what I can do with that is now if I go here, that x value has been stored on my calculator. So I can go ahead and take that x and turn that into a decimal to fraction. And we get 1/84/15. Not so important to write that because, like I said, it is just a sketch. Now, going back to our two equations here, we have y is less than or equal to -x plus 20. So what that is telling me is that for the line that had the y-intercept of 20, we needed to be less than it. So that would be shading towards 0, 0. Remember, you can use a test point to confirm that. If we put in 0 for both x and y, 0 plus 0 is less than 20. So it makes sense. It's shading towards 0, 0. But for our other graph, okay, if we put in 0, 0 for this, 0 plus 0 is not greater than or equal to 92. So for our other one, we actually want to shade away from that. And what we end up getting here is this as our overlap. That is our solution set right there. So we need to find a spot that is in between those two values. So what you can end up doing is just looking at your graph and kind of moving your cursor around after you hit the trace button. So you hit trace. Actually, no, sorry, you don't even have to hit trace. You can just quit out of it, go to the graph, sorry, and just move your cursor around. You don't even have to trace because you can go anywhere. You don't have to stay on the line. And you can find some sample answers. So it looks like 10 is a great value. And you can see as I move up and down, 10.8, 10.7, 10.6, 10.5, those are all in this range. So that can work for you. Okay, so we have a graph that represents all the solutions, but if I asked you to find a sample, you could also do that. Let's look at another one. So here, Marcia is buying plants and soil for her garden. The soil cost $4 per bag and the plants cost $10 each. She wants to buy at least 5 plants and can spend no more than $100. Okay, so she is buying plants and soil for her garden. So let's let x equal number of plants and y equal amount of soil. Okay, I'm just going to put in parentheses bags for that because it was measured in bags. So what we have is now our established variables. The soil cost $4 per bag, so that's 4y. Plants cost $10 each, that's 10x. If I add those together, she wanted to spend no more than $100, so that has to be less than 100. Conveniently, both 4 and 10 go into 100, so if you even had your variables flipped around, this one's going to work out pretty nicely for us when we try to solve for our slope-intercept form. And the other one, she wants to buy at least 5 plants, and that's it. Soil's never mentioned. So if she wants to buy at least 5 plants, that's only going to have an X. So X has to be greater than or equal to 5. So notice this one has a less than, not a less than or equal to. This one had the or equal to part because no more than $100, okay? She doesn't want to spend any more than that. Oh, I guess I should have put that there then. All right, so let's go ahead and subtract the 10x from both sides here. That's going to leave us with negative 10x plus 100. Divide everything by 4. And unfortunately, 4 doesn't go into 10, but not a big deal because that's going to be a slope anyway. So when I divide everything by 4, we end up getting that it is less than or equal to negative 5 halves x plus 25. A y-intercept so far of 25. And well, this doesn't even have any y values in it at all. So I now know I can mark that 25. Okay, now, if we want to analyze this slope here, it's going to be going down 5 and over 2. So because it's going down 5, that's a fifth of the way already, and then going over 2. And then we go down 5 and another 2, down 5 and another 2. It's going down faster than it is over. So we're not going to have to go all the way out to 25 if we don't want to. In fact, you can figure out that the number 5 goes into 25 5 times. So we only have to go over that times 2 because it's going over 2 every time. So 5 times going over 2 each time would bring us to 10. So we can go ahead and make that 10 if we want. So we're going to go back here and revisit our calculator. I'm going to go ahead and clear out the 2 equations from the last problem. And I'm going to enter our 2 new ones, which were negative 5 halves x plus 25. And I can't do the other one because this is a function machine. And x is greater than or equal to 5 is not a function. It doesn't pass the vertical line test because it is a vertical line. So I'm really only using my calculator right now to see if this fits. But I didn't change my window from before. So it looks a little weird and it's not even hitting where I need it to hit. So let's go to our window and change it to 0, 25. Sorry, that should be the y, the range. And the x, we said we only need to go out to 10. So 0 and 10. And if I hit graph, now it's going from one corner to the other. So we can go over here now. There is one of my lines. The other one is just a vertical line, okay, that is supposed to be x equals 5. So here's where 5 would be. So we can go ahead and graph that in. Notice I put an arrow on this one because that does continue on forever. Here, we're only talking about positive numbers because number of plants and number of soil bags can't be negative, so I didn't have to put any arrows on those. Okay, now x was supposed to be greater than or equal to 5. So all numbers greater than 5 for x values are to the right of that. And then the negative 5 halves x plus 25 was less than or equal to. And if I put in 0, 0 for that, 0 plus 0 is less than 100. That should be shading towards the origin. And so we get this little sliver over here as our solution set. It's a little harder to determine what some of those could be because you don't have the other line on the graph. But at the same time, it's not so bad because if I hit trace and I know it can be 5 or bigger and I type 5 in, well, there we go. I have 25 halves. If I type in 6 because that's bigger, that's 10. If I type in 8, that's 5. So anything along those points or even a little bit lower than it, because that's where my shaded region is, would end up being okay. All right, let's take a look at another one. So we have Jonah is going to the store to buy candles. Small candles cost $3.50, large candles cost $5. He needs to buy at least 20 candles. He cannot spend more than 80. If you feel like pausing and want to try it on your own, go ahead, but I'm going to explain it as well. So I am going to go ahead and let x equal number of small candles and y equal number of large candles. So with that, small candles being $3.50 each would be 3.5x. Large candles being $5 each will be plus 5y. And he can't spend more than $80, so that's less than or equal to 80. He needs to buy at least 20 candles. So x plus y itself has to be greater than or equal to 20. And now you know that because of the phrases at least with the 20 and cannot spend more than or no more than 80. So if I rearrange these a little bit, first one's more of the hassle because I have to subtract 3.5x from both sides. That's going to give me 5y is less than or equal to negative 3.5x plus 80, and then divide both sides by 5. So negative 3.5 divided by 5, let's just write that as a fraction, why not, would be negative 7/10. And then 80 divided by 5 is 16. So 16 as a y-intercept potentially? Not so though, because if I subtract x from both sides here, y is greater than or equal to negative x plus 20. So actually 20 is our highest value between our two y-intercepts. So when we go to the calculator to do this now, we're going to end up having to clear out our old ones, or old one, because we only graphed one of them, and we're going to go ahead and put in negative 7/10, which is negative 0.7 x plus 16 for one of our equations, and negative x plus 20 for our other. We know in the window that the highest number we need for the y maximum is 20, but we don't know the other one. So you could do kind of a little arithmetic piece of work to find the domain if you want, like I kind of mentioned in the last problem, but your calculator has a tool for you to do that as well. In the zoom menu option, all right, it's not showing on the screen right away, but if you scroll down a little bit, zoom 0, whether you have an old or a new calculator, is called zoom fit. It's kind of nice because when you hit it, it calculates a situation where you can fit everything you need on a graph. Now you'll notice both of them kind of got cut off on the screen before they ended, but at least it gives you a starting point. You can now go to your window and say, okay, it went up to 10. Oh, but the y minimum changed to 9. That's weird. Let me change that back to 0 so that now I can hit graph and we can see that it wasn't going far enough out. So it kind of gives you like some hints to play with a little bit. It's not foolproof. I'll now have to go to the window and I can see that 10's not far enough out. Let me make that 20 as well. And a little better, but not perfect because it's still going off. So let me up that window for a domain going up to 25. And we go ahead and we look at that there. That one's hitting finally, and that one's hitting as well. So I'll use this as my example. Okay, so the 20 starts high and ends up going low faster. And the one that started at, what value was that again? 16. So I'll mark that 16. Had a more shallow slope to it. It went more right here. And remember, you can figure out what both of those values are by using the 0 command in your calculate menu. So if I go to calculate, option 2, 0, I can go on this first line out a ways, mark a left bound, go down until I see some negatives appear, enter for the right bound, and then try to get pretty close to 0, as close as I can, and hit enter. And we can see that here's our answer, about 22.85 blah, blah, blah. But remember, that's saved here so that I can go ahead and turn that into a fraction if I want. So I know that's 160/7 now. Or, if you wanted to do a little bit of work, you could have put 0 in for y and solved this. So you can do that too if you want. But the calculator is kind of helpful with it. So second calc, back to 0. All right, I'm going to hit down so that now it says I'm in the second graph. All right, and you can see I'm too far negative, so I'm going to keep going to the left until my cursor appears. There it is. Hit enter. Now I'm on the left side of the 0. I'm going to move down until it goes off the screen. Now I'm in the negative area almost. There we go. And so I'm going to hit enter when I'm in the negative area. And I'm going to go as close to 0 as I can. Hit enter, and we get 20. Which we knew was going to happen because this was just x plus y is supposed to be equal to 20. So we have 20 there. If we analyze our shading with the point 0, 0, If we try it for our first one, our original one, which is the more shallow slope line, 0 plus 0 is less than 80. So that one is supposed to shade towards the origin. The other one, to buy at least 20 candles, if we put 0 in here, 0 plus 0 is not greater than 20. That one wanted to shade away. So it's only this small little sliver down here that could have been a valid answer. All right, one more. John is packing books into boxes. Each box can hold either 15 small books or 8 large books. Okay, so notice they didn't say that some box might have small books and large books mixed together. It's just either 15 small or 8 large. Okay, he needs to pack at least 35 boxes and at least 350 books. So we're going to let X equal the number of small book boxes, so the number of boxes that we can use to fit small books in, and Y be the number of large book boxes. Okay? So, if we have that, we know that 15 books will fit in a small book box. We know 8 books will fit in a large book box, and he needs to pack at least 350 books. So this needs to be bigger than or equal to 350. But he also needs to pack at least 35 boxes. So X plus Y also has to be greater than or equal to 35. And so we have to solve this one for Y. I'll subtract 15X from both sides. 8Y, whoa, that's a weird 8, sorry. 8Y will be greater than or equal to negative 15X plus 350. Everything will get divided by 8. Y will be greater than or equal to negative 15/8 X. And then 350 divided by 8 is 43.75, which is bigger than 35. When I subtract X from both sides for this one, I now know my bigger y-intercept is the 43.75. So I'm going to make that the highest value on my y. Let's go ahead and type these in. So clearing out our old ones, I would have, for this one,
I didn't get that.
Sorry, Siri activated. Negative 15 divided by 8x plus 43.75, which I could have written as a improper fraction, but I didn't. That's okay. It's just a sketch. And then our other one was just negative x plus 35, because he had to pack at least 35 books. That's where that one came from. So if I go ahead and hit graph, we have our old window there, which we can see is not good enough, because it's going to hit on an x way bigger. So you could have used zoom fit. Actually, let's try that just so you can see it in action again. Zoom 0, zoom fit is going to go ahead and try to balance this out. For that one's hitting the x up, but that one's still going off the screen. So let's adjust this. So 0 and 25 wasn't far enough out. Let's try 30, and then we'll do our 0 and our 43.75. So if I hit graph now, let's see, does that second line have enough room for it? Nope, still need to go out a little bit more. So we'll go to the window and make this 40, let's just say. That should be pretty good, I would think. And it is. So let's just go ahead and sketch that this one went down pretty quickly. We actually can try to make an educated guess as to where that one's going to go. But we actually should have known that the other one was going to start at 35 because it had a slope of 1 and end all the way out here at 35. So go ahead and hit trace 35, and you will see that if we do that for the second equation that we typed in, it is hitting 0 there. You can barely see it flashing. Okay. The other one, that one maybe we'll have to do second calc 0 for. So I'll go to the first equation. So I'm on the first equation. Left bound, you can see I'm way in the negatives. So I need to scroll to the left until I see the cursor appear. There it is. Okay. Hit enter. Then scroll to the right until I see some negative numbers appear. There we go. Hit enter and then try to get close to 0 by going back left a little bit. And there we go, 23 1/3. And if you wanted to turn that into an improper fraction, you would get 70/3. So we know that's happening here. They were both greater than or equal to. So in both of these scenarios, we need to shade away from 0, 0, because 0 plus 0 in either of these scenarios is not going to be bigger than another positive number. So we have to shade away for both of them, which actually gives us a fairly big solution set area because that's extending out this way since the graph technically continues on. All right, so this video ends up being 25 minutes long. Coupling that with the fact that you had to check your homework means there should be extra like 10-ish minutes. So you might have taken some of that time already if you went and tried 3 on your own like I had suggested, okay? Or now what you can do is also take the time to rewind the video, okay, and look at some other things, or maybe you were pausing as you went and you're right at the end of class now instead. That's fine. You will notice that there's a homework posted. And I hope you all have a great day.